So for 3 by 3 matrices and using them to solve for inverses, these are going to be calculator because we already talked about finding an inverse of a 3 by 3. We're going to use our calculator. You already know the techniques for finding the determinant. There's this technique, or the technique where you rewrote the first two columns, and then 10, 6, plus negative 8, and the red direction, 60, plus 1, minus 8. So if I add up everything in the blue one, you will get 8. If you add up everything in the red one, 53. 8 minus 53, negative 45. So because the determinant is not 0, we know that an inverse exists. And last class we looked at finding the inverse of a 3 by 3 matrix, so we will use our calculator. If the determinant is 0, we can't find the inverse. We've known that already. So here we have a matrix P. You need to find X such that the inverse does not exist.
So P has to equal 0.
So the determinant is going to have to equal 0. So what would we do? Well, if we use the technique where we rewrite the first two columns, that'll be 4x minus 2. 1. Oh, I forgot the 1. 0 plus 4x minus 2. And the red ones, 0 plus x minus 16. So the blue one is 4x minus 2. Subtract, and the red one is x minus 16. If we combine our like terms, we will get our determinant is 3x plus 14. If we want the inverse not to exist, it has to be equal to 0. And if it's equal to 0, then x would be negative 14 over 3. Go back. Okay, we are given A and B. Take out your calculator and use your calculator to find A inverse.
Of which one?
Of A. A inverse will be of A, yes. How'd you do? And do you know how to use your fraction button to get the fractions? Answer to a fraction. And the nice thing now as well is if you've entered this into your matrix A, and you've entered this into your matrix B, and you calculated A inverse, you can store it as a matrix C, or it's not hard to actually write A inverse every single time, too. So now, if we want to find P, such that AP equals B, well, what do we know? I could multiply both sides by A inverse, and remember the order matters. So notice these A inverses are in front, and then you would get P by itself is equal to A inverse times B. Yes. It'd be a totally different question. A times P is different than P times A. You just crush it from both sides. Everybody's good? Okay. Here is, go back for a sec, yes. So if we are solving using the matrix method, the first thing we have to do is change our systems of equations into matrices. So we take all the coefficients, 1, 2, 3, 1, negative 1, 1, 2, 1, 1. Multiply it by our variables is equal to our answers. So we're going to define this as matrix A, this as matrix X, and this as matrix B.
Oh, I don't like X. Why? It's here.
You don't.
X gets used twice.
No, this is a capital. This is a capital X, and this is a little x, as you can definitely tell. Okay.
That's a big.
No, but this is a capital X. This is, guys, this is like 18 font, and this is a little x in 24 font. So you should be able. You get it? You're good? Yes. There we go.
Proportional equation.
All right. I see that Riley's struggling, so I will change the font size. There we go.
There we go.
So we got a big X and a little x.
Now I'm confused.
Yeah, well. Now that nothing's changed, we will continue. So now we can go and just, instead of having to rewrite these things, we can say, well, if I multiply in front by A inverse here, I would have to multiply in front by A inverse there. And that would give me that X is equal to A inverse B. And we'll get our answer. So I'd like you to do this one and the other one. Therefore, ooh, exists. But the exists part, you want a symbol for that.
Or like, you could say is defined. How could I say that? Like, because the defined when it's like 1 over, or this little e belongs to reals.
But it's not a real number. No. Therefore, but the inverse belongs to the group of square. No, there's nothing you can. I would just write exists,
Yeah,
just
say
defined.
If I could do that, do I still have to put it 1 over 9? After I use my calculator, or is it?
But on this one, it's a 3 by 3.
Yeah.
You don't have to do the determinant. You just find the inverse. Oh, am I recording now? I am recording. Okay. We have been.
I'm being held hostage.
Here we go. Yes. So, you get 4, 1, negative 1. I want to show you something on your calculator. I've entered, in matrix C, I entered this matrix. I want you to notice that that matrix has our coefficients matrix and our answer matrix together. Okay? Does that make sense?
Yes.
Can you see it?
Yeah,
Okay, here, I'll just drag it into here.
oh, that's pretty good resolution.
Okay, we'll slide up to our I've got my 1, 1, 2, 2, negative 1, 1, 3, 1, 1, and then here I've got 3, 2, 8. Okay? This is called an augmented matrix. We'll be doing some work with augmented matrices in a bit. Often when you write an augmented matrix, you add an extra line there where the equal signs are. So you have your coefficients on this side and your values on the other side. And one of the things that we're going to lean towards or to learn about is we're going to go to matrix, and I'm going to do math in matrices, and there's a whole bunch of things you can do with matrices, and we're going to go to this one, ref. Okay, and I'm going to see what happens if I ref this one. Second matrix 3. If you ref C, you get a bunch of an identity matrix and the 4, 1, negative 1. So it's basically saying that 1x is equal to 4, 1y is equal to 1, 1z is equal to negative 1. I inputted it as a 3 by 4. Well, actually, what I did, so it saved me some time, is I took matrix A, I stored it into matrix C, and then just added one more column and added the numbers in. That was quicker. That's right. We don't. So there is your answer. That's your answer for B.